In the previous video I presented to you, I was able to run real-time emulation methodologies for centralized radio access network using a frequency domain representation. Now I'm going to demonstrate a proof of concept. The proof of concept that I want to share now is about the static coordinated scheduling technique. For this task, I needed to modify the scheduler function in OpenAirInterface. By default, the scheduler runs for one component carrier and then it triggers for the remaining component carriers. In my version, the scheduler works each component carrier at a time. In this picture, you can observe the organization of resource blocks using the static coordinated scheduling technique for two user ends connected each one to a different remote radio unit. It roughly distributes the same number of resource blocks among user ends. However, if you notice subframes 0 and 5 employ the middle subcarriers, they are empty. That means those resource blocks are reserved for common channels. Let's go to see how the static coordinated scheduling works in OpenAirInterface using the frequency domain representation. First, we need to start the evolved packet core. We see our radio cloud center or centralized unit is connected to the EPC. Then, we observe the two user ends are correctly connected and attached. Then we send downlink traffic from the EPC to each user end. Let's start the remote radio units. After that, I ran the two remote radio units. It is essential to mention that during the emulation, each user end must be connected to a different remote radio unit. In this case, both user ends are associated or connected to the remote radio unit number 0. We get it. The user end number 0 is associated to the remote radio unit 1 and the user end 1 is associated to the remote radio unit 0. In this moment we are waiting for the radio cloud center to start. Let's go inside the radio cloud center. We started the radio cloud center with the T-Tracer tool. Let's go back to the remote radio unit to see what's happened. At this moment, the radio cloud center is connected to the EPC. The two UEs are attached to the EPC and the EPC is sending downlink traffic to each user end. We see two X forms. Each one has the information about each user end. At the top of each X form, we can notice the signal in the frequency domain, but only concerning the out subframes. Then we see the PBCH, PDCCH, PDSCCH, and finally the throughput. Some spikes are related to the information received when we ping the EPC from each user end. After that, We observe the throughput concerning the downlink traffic the EPC sends when we use the iPerf tool. Finally, at the Radio Cloud Center we observe the resource blocks allocation for each user end. In the left part we see that roughly half resource blocks are assigned to the first user end and the other half for the second one.